recording. All right. So yeah, hopefully you guys were able to actually attempt the challenge yesterday. So I know a lot of you guys had Psycopg issues, but hopefully all those got resolved and you're able to complete Chicago Salaries. So yeah, let's actually go through that challenge. So let me clone it down. Fork it. All right, so I have it forked over. I'm going to copy this and then bring up my command line and git clone. All right, cool. That's pretty quick. All right, cool. So let's actually take a look at the README. So I just like reading the web page. So yeah, this challenge had you take a real live data set and then take it from a CSV file and then read in the data, kind of clean it out, and then put it into a database. So first thing, we want to go to the data portal. So let's go there. All right, and let's see. All right, so we want to download this data. Let's see how to do that. Go back, export, CSV. I would love to save that data. All right, that should have been downloaded. And I'm just going to add that here. All right, there we go. So this is my CSV. A lot of records in there. I'm actually going to rename my files to make it a little easier for me to handle. So let's rename it to Chicago Salaries .csv. All right, cool. So again, just taking a look at this data, we have various fields in here. We have a name, job title, department, full-time or salary, denoted as F or P. And yeah, so we want to take this data and kind of, again, cleanse it as in make it formatted to our liking and then put it into a database. All right, so let's go back to our README. All right, so let's create a database. So I'm going to bring up my terminal and create a database. So again, the command to create a database is create db, and then I can give my database a name. So in this case, I'm going to name it Chicago Salaries, and I think I have that database ready, so I'm going to call this Chicago Salaries new. All right, no errors, so I believe my database should be up, and let's proceed. All right, so we want to create a database on my computer, which we did. Then we want to create a table called employees. So again, we have a few fields that we want to add. So let me actually just copy these over. And I'm actually going to use Psycopg for this. So let's actually go through the process of doing that. So let me clear my terminal. Let's get rid of the CSV. All right, so the first thing I want to do is create a virtual environment. So if you guys remember, we do that by typing in Python. Again, if you have Python 3, you might need to type Python 3 depending on your commands. -m, -v, and let's just call this virtual environment Chicago. All right, if you notice, a folder with the name of Chicago got created. Again, this is my virtual environment. So if I want to actually use my virtual environment, I type source and then my virtual environment name, which is Chicago-bin-activate. All right, so if you notice in my command line, again, this is something you guys might have set up during InstallFest, but if you updated your bash profile, you can see the virtual environment there. That's great. And then, all right, so I think we're good to go there. We need to install Psycopg. I'm going to do pip install Psycopg2. Hopefully I have no errors. Let's see how this goes. All right, that was actually pretty quick. So I think I'm good to go there. All right, so let's get coding now. So I think we have Psycopg set up, so we can actually use that. Let me get rid of my terminal. And then we have a Chicago Python file that we need to add code to. So let's go about doing that. All right, so the first thing is, I know I'm going to be using Psycopg, so I'm going to actually import that. There we go. And then let's actually get started with creating a database table. That's, I think, our first task. So using Psycopg, we need to establish a database connection with the database that we have. So I'm going to create a function for that and call it connect to database. All right, and then this will use Psycopg. So I'm going to do connection equals Psycopg to connect. All right, so connection takes a couple parameters, I guess one being your username and the database name. So DB name is going to be what I just named my database. In this case, it's Chicago Salaries new. And then I have a user. So this is all one string. So I guess it's one parameter, but the connection will parse this. So I need a user. So in this case, we're going to use get pass. So again, this should have been in the documentation. Just kind of following that. And in this case, my user is going to use get pass dot get user. So I know some of you guys might have had issues with get pass. Hopefully, you guys were able to find a way around it. And okay, so I think I have my database name correct, and then this should get my user if everything is up and running correctly. So here's a topic. I don't know if we've covered this in detail or even mentioned before. Let's talk about error handling. So this is a good candidate for error handling. So if you guys might have seen this in code before, we have something in Python called a try except block of code. So this is a common way to error handle. In JavaScript, it's try catch, but essentially it's the same thing. So the way this is structured is anything you put in your try block, it's going to kind of protect it, as in if something goes wrong in your try block, instead of your application kind of just like ending or crashing, your except block can actually handle the error and kind of gracefully deal with it, as opposed to ungracefully being your application kind of just halting and stopping and freaking out. All right, so in this case, I'm going to put my connection attempt in my try block, and for let's say something goes wrong, my accept should be able to give me some information. So in this case, I'll just write a simple print statement saying error connecting to database. All right, so this will be printed out, but my application will continue running, as opposed to if I had an unhandled exception. In this case, if this line of code threw an exception and I did not handle it, my application would basically terminate. All right, so let me get rid of my duplicate line here. So, okay, as always, as you're developing anything software related, it's good to kind of test incrementally. So I'm actually just going to test my database connection to see if I actually get an error or if I happen to connect. All right, and then, so that's my simple function, and I'm going to call my function connect to database. So let's say if I connect successfully, I just want to see a helpful message, because the terminal usually doesn't show me much. So I'll just say success. All right. So again, if I connect successfully, it should proceed to the next line and print this out. In this case, the accept block will not be called. The accept block only gets called if an error or an exception is raised from your try block. So again, this is error handling in combination with testing and debugging. These are the skills you need. You gotta make your code safe. So that's where error handling comes in play. You obviously want to make sure your code works, and that's where testing comes in play. And then obviously, if something goes wrong, you want to hone your debugging skills to kind of easily find the errors and fix them. So definitely tools to be aware of. All right, so I'm going to call connect to database, and I think that should be all I need. So let's just have basic comments. All right, so let's give that a try. And actually, bring up my terminal here. There you are. I'm going to run chicago.py, and hopefully there's no errors, but you never know. All right, cool. I got success connection to database. I think I wanted successful here. But cool. So as far as I know, I'm connected to my database via my Python code, so that's a good start. Let's just hypothetically see what would happen if I had an error. So let's actually modify my database name and say new underscore x. So this database does not exist. I've not created it. And let's actually run this again. All right, so in this case, as you can see, the printout statement was error connecting to database. And that's because of this except statement. So some exception was raised. In this case, obviously, this database doesn't exist, so connection would fail. Again, I don't actually quite know what the exception that's raised. You could actually specify the type of exception, like it might be value error, for example. In this case, I don't think it's a value error, but there are specific exceptions you can catch. So for example, if you know this might throw a value error, you can handle that. And then if some other exception gets raised, you could have another except block here to catch all other exceptions. All right, again, so value error is just a type of error. In this case, it's not the appropriate error that's being raised. So actually, I'm just going to catch all errors and assume that I can handle it with this one case. All right, but I actually want to connect to my database that exists. So let me change that. And let's continue adding to our code here. So again, this is all from documentation. So once you have a connection, you want to return a cursor. So the cursor is kind of how you interact with your database. So in this case, I'll return connection.cursor. All right, so my function now is actually returning something. So since I'm calling a function here and I'm getting a return value, I actually want to store that return value in something. That's how return statements work. But there's potentially one problem here. If I have an exception, my connection object is not going to be anything valid. So this is actually not quite kosher, because if this fails, I'm going to print out my error statement and then still try to return my cursor. So there's another block you can add, which is called finally. Sorry, this is not the right block we need, but let me talk about finally since we're talking about try except. Finally block is something that will always execute regardless if you get an exception or if your try statement completes this exception. So again, the code you write here always will execute. But in this case, as we pointed out, this connection is only valid if it gets created successfully. So I'm going to actually add by return to my connection statement. And then in my finally, I'm going to write return none. So what's going on here is if everything goes well here, only lines of code I'm going to execute are 8, 9, and 10, and I'm going to return. So this finally won't actually matter, as in it won't execute. So this will return none in the error case. Maybe if I want to just make this a little better, I'll return none in the except case. So either I'll do a try and then return, or I'll do an except and return none. So always good to check if you're returning something that could be none, check your cursor. So I'm going to check is not none. All right, so my cursor may or may not be valid, so I actually got to check it. In this case, I want to check if it's not none. I want to proceed using my cursor. Okay, so let's actually create another function. Always good to have functions instead of large blocks of code. In this case, I'm going to call my function create table. And then since I actually know what my what my task is here, I'm just going to be more specific. I'm going to say create employees table, since I know what type of table and the fields I'm going to have. All right, so in this, I'm actually going to use my cursor. So I actually have to pass it in. Again, this cursor exists in my, global scope, but this function has no real idea of this cursor because this cursor isn't defined yet. So in this case, I'm going to just pass in the cursor. All right, and then I'll call my function from here. So create employees table. All right, and pass in that cursor. Again, this is only going to happen if my cursor is not none. If it's none, then this won't happen, which kind of makes sense because we don't have a database connection, then we can't really create a table. All right, so we create a database connection, and then we want to create a table. So let's go back to our README. Again, we have these fields, so I'm going to copy it again in case I copied something else in the meantime, and let me copy it in there. All right, so I'm going to put that here in a comment. All right, so I need to create a table and have these fields in there. So let's actually go about creating this table. So we need to write a SQL query. So I'm just going to kind of write that in a block comment. All right, so let's write some SQL here. So if you guys remember, to create a table, the command for that is actually create table. Then we won't need to give it our table a name. So in this case, I'm going to name my table employees. And then we want to specify the fields. So we have first name. So, or actually, we should start with an ID. So in this case, my ID is going to be, let's say, serial primary key. That should work. Comma, and then all these fields. So first name, we're gonna probably have that as a string. So varchar would make sense here. I'm gonna assume that no first name is longer than 64 characters. Hopefully the Chicago Salaries database is having longer than that. And I wanna make sure that I have an actual valid value. So that's what the not null will do. The not null will say that you can't have an empty value for this field. Likewise, last name, do the same thing. Not null. Then we have job title.
Yeah, first name.
Don't forget to change it.
Thanks, guys. Pair programming, love it. Job title, and I'm gonna have my job title also be 64 characters. Again, hopefully there's not a super long job title out there, like assistant to the regional manager of Chicago proper. That might exceed it, but I don't think that's the actual job title. So then we have full-time or part-time. So again, looking at our data, kind of want to make sure that these values make sense. So full-time or part-time is always denoted with a single F or a single P. So in this case, since I know that's kind of what my data is going to be, I could kind of just, I could kind of just assume the data is going to be formatted correctly. And again, I'm going to be the one inserting the data. So if I get something that's invalid, as in like someone wrote full-time instead of an F, I can handle that in my software layer, which is the Python code, since I'm controlling the data I'm inputting. So we're not simply just reading the CSV data and straight putting it into a database. There's going to be a process of cleaning the data or sanitizing the data before we enter it into the database. So full-time or part-time. And this I'm just going to have a varchar of 1. I guess technically I guess make this a char of 1, but I'm just used to using varchar. Again, might be an extra couple characters, but I just use that. And a couple more. So we have department. I'm going to start copying here. Typing. So I have department, and then I also have annual salary. All right, and then these will be, I'm going to make this numeric because it's going to be a floating point number most likely, and then department will also be a varchar. Let's call that 64 and not null. So all these are going to be not null. I'm not sure if there's an easy way to say every field it's got to be not null, so I think you guys specify and not null.
The way annual salaries stored, some of them are empty. If they're paid hourly, it's in a separate column.
Gotcha. So yeah, I think in this case, we're going to be taking in the data and always converting it into annual salary. So again, yeah, the CSV file might not have annual salary as a field in every case, but we're going to actually guarantee that we're going to have a salary put in there. But yeah, thanks for that note for sure. All right, so we have our create table. Don't forget your semicolon. I always seem to forget it. So this is a rare case where I actually remember it. All right, so these are our fields. Again, using varchars, we have a primary key, which is going to be auto-generated for us. That's what the serial keyword does. And
do you have an extra, do you have an extra parenthesis after not null on annual salary?
Yes, I do. That's actually the closing parentheses here, so you're right.
Okay, because I saw an extra one below.
Nope, you're right. I didn't need it there. I have my parentheses on a new line, which is usually good practice, kind of line up your parentheses. So since my parentheses opens here, I kind of want to close it on the same tabbing line. So thanks for pointing that out. That would definitely would an error. All right, so this is my SQL, but actually you need to run that SQL using my cursor. So to do that, I call cursor and execute. And then I could just use a string. So let me have that and close my parentheses. All right, so yeah, I think this should be creating my table. We obviously want to test it out. So one thing, if you guys remember, always want to make sure you also drop a table, else your table, like if I already have a table named employees, then I won't be able to create this table. So always good to kind of drop your table just in case. So in this case, I'm going to write another SQL query. And this will be simple enough, so I'm going to keep it on one line. Drop table if exists, and that'll be employees and cascade. All right, since I'm using the same name a couple times. I might as well use a variable in case I want to change it later. It'll just be easier that way. So I'm going to create a table name and pass that there. Again, if I wanted to make this more generic, I could have this function take in the table name instead of me hard coding it here. But in this case, I know I only want the one table right now. So again, if I want to modify it later, no, will this work? Can I format this? Yes, I can. All right, so I have a table name as a variable. In this case, it's just employees, and then we're going to drop our table and then create. All right, so let's test this. I'm going to keep my comment here because it might be helpful. But all right, so my cursor is not none. I'm going to call employees table with my cursor, and that will execute a couple of SQL queries. So again, I want to actually use a try catch here because again, something could go wrong. I can't anticipate what might happen, so I'm just going to add a try block. In this case, everything I'm doing here, and then an accept block. And I'll just have a simple error message telling me what happened. All right, so this is going to be error creating table. And let's get some nice feedback if I was good at what I was trying to do. Spell that. All right, cool. So let's test this. Let me bring up my terminal. Bring it up a little bit clear here. And then run this. All right, great. Getting some good feedback. So I created my table. Again, that was in my try block. So if I look at my try block, I have, sorry, it's kind of bulky. I have my try block here. I did a couple SQL queries, and since that was successful, my print statement of create a table got executed, and my except block never gets executed because there's no error that was raised. If there was an error, it automatically go to here. Like if it was on the first line, if there was an error on this line, it would fail there and go to my except block, so my second line would not execute in that case. But since I was successful here, it proceeds to the next line. And then if there was an error there, again, it would go down to my except block. But in that case, I successfully created my table, so then I was able to proceed on to my next line of code. All right, so that's creating your table. And then I guess the hard part of actually taking in the CSV data and then sanitizing it if we need to, and then adding it to our table that we just created. So let's get that going. So I know I'm going to need CSV because we're going to be dealing with a CSV file. And all right, let's create another function here. So this function will be called read CSV file. Not really creative with my names here. All right, so in this case, I want to read my CSV file. So let's give that a try. So again, I'm going to use a try block. Again, always kind of just practice if something could go wrong. Again, your CSV file might have the wrong format or might have the wrong name, like might be a wrong location. You never know what can go wrong with external components. So usually good practice is just have try except blocks when things can potentially go wrong out of your control. All right, so in this case, I want to open my file. So my file is called Chicago Salaries. CSV. And I want to read, so I'm going to specify an R operation and then give this name alias. So we'll call it CSV file, generic. All right, cool. I'm actually going to use a dictionary reader. I feel like the functionality there is good. And so to use a dictionary reader, I simply call or create a dictionary reader object and pass in the CSV file. So hopefully you guys know that from last week. Pretty simple to do that. And now I'm going to go through each row. And that's going to be formatted in dictionary in my file dictionary reader. And again, I just want to quickly test. So I'm just going to print out what my dictionary looks like just to kind of inspect the data and see if everything's going right. Then obviously you want an error statement if something went wrong with my file.
You also might want to like bail after 10 lines so you're not reading the entirety.
Yeah, you're right. Thank you. I'm just going to break after the first line. Thank you. Yeah, I was thinking that it's going to be a long terminal output if I don't do that. So error reading file if something goes wrong. Okay, so I'm just going to print out one line. So the break statement, again, hopefully you guys are familiar with this, will basically exit out of this for loop once it hits. So I'm going to print one line and then break. And I think the first line might be a header. So let's, I don't know, let's create just a counter and print out a couple lines. I'm actually not sure if it's the header, but we'll find out. All right, so I'm going to have a case here if I is greater than, let's say, 3. So we'll print out a few records. All right, hopefully you guys are following along here. Let's give this a run. And can I
Is
see
that an extra colon there?
it is? Thanks for the added eyes there. All right, so let's let that run. All right, so actually I'm not calling my function, so that's my mistake. Let's call our read CSV data. And again, just to be more safe, I'm gonna actually return a Boolean here. True indicates I was successful, and then if I hit my except case, that'll be return false. Again, this is my creating data, creating my employees table. So if I was successful, I'll know because this function will return true. Not sure why this stuck here. All right, so let's actually check the return value here. So let's just call it success equals create. And then if success, again, I could be more specific here. I could compare this equals true. But in this case, I usually just prefer, if it's a Boolean, I just use the Boolean value straight up. Read CSV file. All right, and then this should print out our records. So hopefully nothing wrong there. All right, cool. So reading some records here. Looks like the first record is not a header. So first record, Aaron Jeffrey M. Let's actually look at our SQL data, or sorry, CSV data. Yep, our first record is Aaron, comma Jeffrey M. And it looks like we're getting the data correctly. Yeah, so it looks like we're getting the data we want. So we can proceed. Let's actually do something with our data. So let's get rid of this counter. Don't need you anymore. All right, so it's going to go through every line and print it out. But in this case, I don't actually want to print it out. I actually want to store that data in something that's useful to me. So let's actually create a dictionary that can store our data. So I'm going to say kind of a long name. Maybe I should get rid of the data. All right, now it's going to be dictionary. Actually, no, it's going to be a list with dictionary values in there. So Chicago list. All right, list here, and I'm going to append these dictionary items to it. So it's going to be a list of dictionaries that I'm storing here. And let's simply return that out of this file. And we're doing a lot of returning, but again, we're keeping it modular. So each function's doing one specific thing, and we're not kind of combining like 4 different pieces into one giant function. So I want to return my Chicago salary list, and then if I failed, I'll return an empty list. All right, so in both cases, I'm going to return some sort of list, so I don't actually need to check the list is. If it's empty, then I'm not going to actually store any data. So I think that should be fine. So let's get data list equals the return value from read CSV file, and then we proceed to do something. So let's create yet another function. And this function will be called, let's just say, what should we name it? Let's say Sanitize Data, maybe. Let's say insert data. And it's going to take in a data list. All right, so that's the data list here. So again, if it's empty, it's still going to be valid even when we had an error, so we don't actually need to check the values. We could just do something like calling a function. So let's call insert data and pass our data list. All right, so again, you could technically call, like I could create this function above and then kind of call it from my read CSV file, but I kind of want to just keep my main logic together, which is going to be here, rather than having one function call another function. Again, that's not necessarily wrong. I just prefer to have all my central logic in one place. So insert data, pass it a data list, and then I want to use that data and actually write a SQL query to insert it. And again, we might have to do some sanitization, so that might be an intermediate step. But right now, I kind of want to just see if I can insert something. and see what happens.
Ankur, can I ask a question or should I wait till the end?
No, absolutely. Questions are more than welcome.
I have a question about like the design style why use a list? Why use the dict reader if we're going to save it as a list?
Good question. So the reason I have it as a list is because these records are, again, like they're kind of ordered. Like I want to have an ordering. I guess the ordering isn't that important, but it's a list because it's collecting a list of dictionaries. The dictionary actually has the data I want. So each row is an entry in my list, and the row is composed of an entire dictionary. I don't know if that makes sense. So if I had a dictionary with just my, with the field names, I would have to have a list of every name that comes in there. Does that kind of make sense? So like I have maybe 1,000 rows in here, or maybe more than 1,000 rows. If I only had a dictionary that had like a name field, well, I need to have 1,000 records for each name. And then I would need another list for each row in my job title. So it'd be kind of the opposite way, where you have a dictionary and then each dictionary entry is a list containing items from each of your rows, as opposed to having a list of dictionaries. So each entry in my list corresponds to each row in my input data. So this will be a dictionary. This will be a separate dictionary that's also added to that list. Did that make sense, or did I lose you further?
So you're saying there'd be a lot of redundancies, or?
No, it's not even redundancy. So I guess let's explore your option. So I think you're suggesting have a dictionary here. So let's call it Chicago dictionary, and this would be a dictionary. So I guess if you can kind of walk me through your thinking, we can maybe talk about it. So I have a dictionary now. So what should I do with this dictionary?
Well, I'm guessing you would update it. Instead of appending, you would update the dictionary with the row information or the line information.
Okay, so in my dictionary, what are my fields going to be? It's going to be like first name, last name?
Yes.
All right, so one negative of this is I kind of have to know ahead of time what the values are versus I get the fields automatically from my CSV file. But let's actually go with this and see what happens. First name, and this will be blank to start off with. So what's going to be my entries here? Is it going to be a string, or is it going to be some other object or type?
String.
String, okay. So we have that, and then let's just say last name. And I'm not going to actually do this entirely, but I just want to ask. So I have this dictionary, right? Then I'm going to have the dictionary here. So I'm going to have Chicago dictionary, and then first name. Curly brace. And then what would I do here? Would I do something like line dictionary first name? Is this kind of the idea you had?
Yeah.
Okay, yeah. So again, we do have this dictionary, and then we do get a dictionary we want to store. But again, when we get to our second line in this file, what are we going to do with this dictionary? Are we just going to overwrite what we had before?
Yes.
Right. So then I guess what do we do with our first record then? Right. So that's actually the reason we have a list. So the list is going to keep track of each row. So the first item will be one dictionary, which we read out, and then we actually store the second dictionary in the second index in the list. So that's the reason I have a list over here. So it's going to contain each row information for each index in my list.
Okay.
Make sense?
Yeah. Thank you.
Yeah, no, good question. I'm glad, again, anyone, if there's any other questions about anything I'm doing or just in general, please stop me because I hate talking for long periods of time. All right, cool.
So you're saying that a list would store it and a dictionary would just overwrite it or overwrite it?
Sure. Well, so the idea there was we had one dictionary. So let me talk about how this could work. So if we had a dictionary with all the fields, so imagine we had first name, last name, job titles, etc. We could use a dictionary, but in this case, we will need a list here. And let me just kind of talk about how that works. So in this case, my Chicago dictionary has an entry for all the headings. And then each time we need to append, again, because we have like thousands of rows. So we need to keep track of each row record. We don't want to kind of lose the data once we extract it out. So in this case, I could append the information from, sorry, this should be Chicago. But as you can see, it's more writing if you do it this way. And also you have a bunch of lists that are kind of in sync. So in this case, if I went with this method, my first name field would actually be in list, and that'll have 1,000 records, or however many records I have in my file, containing all the first names for each of these rows. So I'll store Aaron, Jeffrey M, and then Aaron, Karina into my, sorry, I guess that'll be the first names, but I'll store like Jeffrey here, and then Karina, and then I'll keep appending to this list. And then I would have to do the same thing for my last name and then all my other fields that I have. So again, I would have a dictionary with each field being a list, because that list keeps track of each row. But that's a little more complicated because I got to do that manually. But since I'm reading in a dictionary, I can kind of just store that dictionary automatically into a list rather than having a dictionary of lists.
Cool, thank you.
Ankur, we use the dictionary for my group. What we did was for each row in your loop there, we had a function clean each row and then execute the insert into for each row. So that way you're not storing the data in a list, you know.
Yeah, actually, that might be more efficient. I like that suggestion. So the suggestion there was basically, as you're reading in the data, kind of sanitize it right on the spot and then write it straight to your database. Definitely another approach. Again, either, I guess, this approach or that approach, like neither is better necessarily. It's kind of just user preference. So I like that you guys are kind of came up with that solution. Again, in this case, I kind of want to have each function kind of do its own thing. So that's why I'm actually going to store all my data. So slightly less efficient because I'm actually storing all my records in memory. But in this case, I just want to have that design where I can separate it out and kind of store my data internally before I write it out. So yeah, that could work also for sure. All right, so let me go back to my list design. And I want to just append my line dictionary. All right, so again, this is a list. Each entry in there is a dictionary, and then each entry in there corresponds to one line from my CSV file. So let's, all right, let's insert data. So I'm gonna do a try again, and then accept will be some statement saying I failed. All right, so let's actually write a SQL query. So this is going to be insert. All right, so this will be how I insert. So again, this is going to be SQL that I'm writing. So in this case, it's going to be insert into, and then my table name is employees. And then actually, I'm just going to make a quick design change. Apologies for kind of bouncing around here. I'm just going to extract this table name outside in case I want to change it later. I feel like all my functions should be using the same table name. So I'm just going to create a table name here, and that's going to be passed to my create table. Make that more generic. And it's going to also be passed into my. All right, so let's kind of make this again more generic. I don't want to necessarily hard code this because if I want to change it, it should be easier. In this case, I could use table name here. If I pass in table name here. Okay, so all right, cool. Let's proceed. All right, we're creating our table, reading our data, and then finally taking our data and inserting all the rows. So we're going to actually need a for loop here for data and data list. All right, let's get our insert statement going. So if you guys remember your insert statement syntax, it's insert into, then you give the table name, and then you gotta specify the fields. So in this case, I have first name, and this is where actually I might want to, yeah, I mean, it's not great design because I'm actually gonna be repeating this. So I might wanna extract this out further, but I guess maybe in the interest of time, I'm just gonna copy and paste here. And then use the same field name. So again, these field names are hard-coded. Again, not great practice, because again, if I change my field name in one place, I'm gonna have to change it in multiple places. So I probably could do this a better way if I wanted to take a little more time, but I want to just quickly get this inserted and see what the results are. All right, so those are my values I'm gonna insert. Oh, sorry, my fields, and then my values will be in a separate line. So I don't know if you guys came across this formatting issue, but The issue with single quotes and double quotes is kind of tricky. So in this case, I'm going to actually use a formatting option. So each one of these is going to say I'm going to provide a value later. That's going to be a string. All right, so I have 6 values, I believe. First name, last name, job title. Yep, 6 values. So I have 6 input values I'm going to put in. So again, this is a formatting option, which we'll kind of give values to later. All right, and then insert values. And that's going to be my dictionary. All right, so we'll create, I think we need a tuple here, data and fields. All right, so again, I definitely would want to create some header information about this because I feel really bad copying and pasting all this, but I'm going to proceed with it for now. If you guys aren't familiar with the backslash character, this is such a continue a line in Python because normally when you add a new line, it's going to be a new line of code. In this case, I want to continue. Maybe I don't need it for commas, we'll find out. Data, last name, lots to type out here. Data. And all right, cool. So these are going to be my actual values because that's stored in my data dictionary. It's going to extract those values and pass them in to this place right here. I need a semicolon here. And right. So if I do something
You need to put those in, you need to put a call to that inside your block comment, right?
You mean like how to get this into here?
Yeah.
Yes, I think execute actually will let me do this. I'm actually going to try this. So I do just insert command and then pass in insert values.
Okie dokie. I can see that.
All right, we have that. Again, we're going to need to sanitize our data, so I'm going to expect this to fail because I think annual salary will fail if not there. We'll actually, see that fail and kind of fix it afterwards. So I have my for statement here, or for loop here, and then insert values, I guess, is this. And all right, let's give this a run and see what happens. I'm going to expect it to fail. All right, bring up my terminal.
Looks like you're missing some commas and insert values.
Insert.
After the values and insert values, there's 2, yeah.
Thanks again. Extra eyes. All right, let's clear this and let's try running this. Again, I expect it to fail. I assume it's going to fail on inserting a row because I'm not going to have annual salaries and there might be other issues. I think last name and first name need to be sanitized. That's currently one name field. So it's actually, I think about this. All right, I'm actually not going to run this because I know I need to sanitize my data. So let's create another function called Sanitize Data. Okay, so the job of this function is going to take the data from the CSV file and then format it to what we want it to be for our database. So again, we can't always expect it to be perfect. So let's just make this one data item and let's see. So we'll call Sanitize Data here. All right, again, so this function is simply just going to go through our values and kind of fill in the correct data. And that's what I want to do. Make sure. All right, I kind of see an error with my logic here, so all right, data. I'm going to create a Sanitized Data dictionary. And then turn that.
You add dict to the end of that, so we don't, not confusing the function and the variable.
Yes, that would be not great. All right, so this function is actually going to take my input data, convert it to a new sanitized data, and then return that. So I can just use that from here. So let's say sanitize. All right, so we're getting close to the finish line. So almost there. Just gotta make sure our data is sanitized and then test it out. So in this case, we're creating a dictionary. I'm going to use our data dicts and kind of pass them values. So if we look to edit our data before, we're extracting. It's formatted as last name, comma, first name. So we got to figure out a way to kind of parse that out into the first name and last name. So let's actually go about doing that. I think I'm going to use regex, one of the tools from before, and just go over that. There might be other ways to do it, but I'm just going to go with this. So if I want to use regex to do this, I'm going to do with my sanitize function. All right, terminal can go away. Sanitize. All right. So in this case, I want to use match equals regex search. And then, so I actually have this coded up, so I'm just going to copy and paste it in the interest of time. All right, so I have my regex. It's this gross looking thing. So basically, I'm going to match something, look for a comma, and look for potentially any spaces. So in this case, it's going to be 0, 1, or 2 spaces, but maybe I just want to make this generic and say any number of spaces. Then I'm going to look for another block of stuff, and then space potentially after. So I think this should find the info I'm looking for. So let's pass data dictionary to that, and then do match group 2 because the first name is actually second after comma, and then sanitize data dictionary last name equals match.
So will that work for people with the last name like O'Brien? Because in that it'll store O as 1 as the second value, and then Brian would be the third.
Let's take a look at that. Was there an
No, you should be good because there's a comma in between. So it's everything before the comma is getting stored into one value.
Like we have an example here of Boyle.
Oh, so everything before that.
Yeah, so basically my regex is saying this comma kind of separates the values moving forward. There might be extra space. Basically, the first group is my last name. The second group is my first name. And yeah, so this space will be kind of handled.
Oh, nice. So that'll work. Any like first names like McAllister, like McKinnon would be 2 values, but it'll merge those together too. It stores first names as like separate values if it's like that too for some reason.
Yeah, we'll check. We'll definitely want to make sure this regex works correctly. I might be incorrect here, but what testing is about. All right, so let's just complete this. We have job title. In this case, I don't think I need to sanitize anything there, so I'm just going to do a straight copy. So like this. Again, just to reiterate, I'm using hard-coded, field names. I would probably want to centralize this somewhere, just to make sure, like, if I have a typo, it doesn't really propagate elsewhere. I can fix it easily in one place. But this, the way I have it right now, like, if this field name changes, I'm going to have to go through all my places in my code to change it. So, kind of bad practice here. We can maybe clean it up later.
Are you talking about like create a value for it and then just insert that value instead of hard coding?
Yeah, I think I would create like just a simple list that's my headers, and then I could just reference my first header, second header, or maybe even better, I'd create a class. So I think that's where classes come into play. So maybe I should explore that option also. Like so, the class would just basically the class would have these names kind of coded in, so I could just reference a variable called first name, and then if that changes, like the variable is going to update and it'd be easy to read. Versus like if I had just a list, I'd have something like row, it'd be like header 0, and this would correspond to first name. But actually, this is not really user friendly. Like reading this as code, like I have no idea what header 0 actually is. So it might be better to have like a class that's like header, and I could do first name, and this first name would actually contain the value of my header information. If that makes sense.
Got it. Yeah, thank you.
I went down this path, so I'm just going to stick with it. We're kind of running long here. And job title. What else do we have? We have full-time, annual salary. All right, it's going to be straight copy. Department also, we have straight copy. And then our annual salary actually is going to require some work. We talked about that briefly earlier. So it's be department. All right, last thing is annual salary. So for annual salary, we have this note here. If an employee is an hourly employee, calculate their annual salary by this equation. So hours per week times hourly salary times 50. All right, so in this case, we're going to do some math. All right, I'm going to create a variable called annual salary. If our data dictionary has something for, I believe those. All right, we have annual salary as a field, but then we also have hourly rates, and then stuff after that. Typical hours. All right, so we want to investigate this first. So salary or hourly, it's going to be a value of salary or hourly. So let's use that to determine if we want to proceed. All right, so I'm going to copy that. That's our header name. All right, we have salary. We can just set annual salary equal to the data from the salary field. So take your data dictionary and find that value. So go back to that CSV file. Annual salary is the header for that. Title. All right, so I'm going to update all this because I was not using the correct names. Again, another reason why if I had done this in a better design, I could just update it in one place and be fine with it. All right, so this is my CSV data. That's what data dictionary has, and that's why I got to use the proper field names here. So we have full-time, job title, department. This will be name. And we're doing this correctly, I believe. All right, so annual salary. Else, if they're an hourly worker, we want to do something else. So in this case, annual salary will be equal to 50 times their hours. So hours equal annual data dictionary. Now let's go back to our CSV file. That is typical hours. All right, so it's the hours they work, and they have an hourly rate, part of our equation. Let's call that hourly rate equals data dictionary. All right, so I think we got all the values to compute our annual salary if they're an hourly worker, so it's going to be 50. So it's hours per week. So let's do that in order. Hours is hours per week, and then that's going to be multiplied by hourly rate, multiplied by 50 for the formula they gave us here. So in this case, we have a value for annual salary, and then we'll apply that to our annual salary field. All right, so we have our 6 fields set. Again, hopefully this works correctly.
You don't have to denote those as like floats or integers. But
Oh, you're right. You're right. Thank you. So let's just convert this to a float. I think that should work for a string.
You need it for the multiplication section as well.
Yes, thank you guys. That would make much more sense. Can't multiply strings together just like that. So in this case, annual salary should be good.
Before you get too far, line 70, you've got it listed as sanitized data dict, whereas 71 and forward, it's sanitized data dict.
Ah. Thank you guys for error checking. Plenty of errors today. All right, I think that should do it, but we'll see. All right, so I've sanitized my data, scanning the values I want from my CSV file, transferring it to the values I want for my database, returning that dictionary, and then hopefully it's correct here. But we'll obviously test it and see what happens. So I think I have everything I need. For loop goes through each row. I'm going to do an insert command for each row, call execute, and if I fail, I'll print out. All right, let's give this a run. I think there might be errors because I never trust myself. But all right, so insert data is going to do that, and let's give this a run. I'm typing for too long without testing. All right, so we're going to run Python Chicago.py. And of course, we got something, insert command on line 93. I have to indent on line 105. 105 is here.
It needs to be at the same level as the assignment in the previous statement.
I think this.
No, at the insert command indentation level, because technically the block string isn't a new block of code.
I think that's, yeah, okay. I think that was it. We'll find out. All right, getting progress. Name create table is not defined. That is line 125. Probably just pass it in. 125. Oh, so I renamed my function. You are just create table. All right, getting through errors. Hopefully there's not too many more. More errors. 125. I'm not pass in. Create table. Create table. Create table. Create table. Create table. All right. How many more errors do we have left? All right, we created a table. It's taking a while, so it's either hung up on something or we did it correctly. All right, so we didn't get an output. So in my insert data, I actually don't have a successful output, which I probably, in hindsight, should have done that. So Sanitized Data. Okay, so I ideally wanted a print statement here. I'm not going to run this again because it's going to conflict with the data I have. But let's actually see if my data was correct. So let's run a select statement. So I'm going to go into pSQL for my database, which was Chicago Salaries new. All right, I'm in SQL. Let's run a query. Let's just select select employee. All right. Table not exist. Let's find out. No relations. Interesting. What's going to see here? All right, for some reason my table did not get created. Oh, I know why. So, got to read documentation. So we need to actually commit these changes. So that was my bad. All right, let me wrap this up. So insert data, assuming that's true, we'll do cursor commit here. And so this will actually execute all the SQL we've kind of stored up there. And we want to do cursor.close and close our connection also. Forget about these. Again, this is in documentation, so I should have been paying attention to it. So cursor commits, we should close our cursor regardless, and our connection closed. All right, we're going to return connection from here so that we could actually close it later. If you guys are following along, I'm bouncing around really quickly here. So this is going to be our connection objects, and then connection not is not.
You're missing an N in the first connection.
Yes, I am. Thank you. If connection is not none and connection that cursor is not none. Right, and then we want to close our connection also here. All right, I think that's all the required stuff. All right, guys, so to continue the Chicago Salaries challenge, I fixed up my code. Apologies about the issues earlier, but yeah, let me walk you through my solution now. So just to start, I have a few imports here. I'm importing Psycopg, and this is for Postgres integration. Using getPass to get my username so I can access my database. Using the CSV module because I'm going to be reading a CSV file, and I'm going to be using regex down below. All right, so to start, I've created two very simple classes, and these classes are primarily just to give me identifiers for my database fields and for giving me identifiers for my CSV headers. Again, this is so that I can have one central place for these values in case they change or in case I have an error, and I will use these values throughout my file. All right, and I'll point those out where I'm using them. All right, so these are just convenience classes that I created. Let's continue. So I created a connect to database function. Again, the primary job of this function is to set up a connection with my database. So in this case, I create a database called Chicago Salaries New, and that's the database name I pass in for the DB name parameter. And then as my user, I use getPass.getUser so that I can log in. So the connect method takes in the string and will parse the parameters out for DB name and user, and then get a connection object back. I print a success statement if this is successful, and I return that connection from this function. I also have set up a try except block here, and this is for error handling in case something goes wrong with my attempted connection. In the event that an error does occur, I will print out a message and display that error so that I can debug more easily. In that case, I'll return none as my connection object because I have no connection object to return. All right, and then I have a method called createTable. CreateTable's job is to do two things: drop any existing table and then insert a new table. So again, I'm writing SQL here, and note that I'm using my field class that I created at the top of this file. Again, this is just to have a central place for my actual field name values. All right, so I create my command. I use string interpolation to insert these values, and then I pass my command to my cursor. Note that my createTable method takes in two parameters. One is a table name, so that I can keep this generic, and a cursor object, which will allow me to execute my SQL. All right, on success, I actually print out a message just to give myself some feedback, and then print out return true, indicating that this function returned on success. However, I also have another try except block. If anything goes wrong in my try block here, I will catch that error in my except block and simply print out that error and return false, indicating that this function call was not successful. All right, so this is my createTable method. Next up, I have a read CSV file method. This takes in no parameters. The goal of this function is simply to read my CSV file. In this case, I've hard-coded that file name here. Maybe better practice might be I could take in a file name in case that file name changes. But for now, this will do the job for me. So I'm simply creating a list of data objects, and those data objects will actually be dictionaries because I'm using the CSV dictionary reader class here. So I'm going to loop through every row in my CSV file and extract the information as a dictionary, and then append that dictionary to my Chicago salary list. All right, on success, I will print out a message and return the salary data list that I was compiling from the CSV file. As always, I have an except block to correspond to my try block. In case there's an error with the file reading, I'll print out that error message and print out the error, and I'll return an empty list because I have no data to return. All right, let me skip down below. Finally, I have an insert data method. This takes in 3 parameters: a table name, a data list, and a cursor object. So I actually don't need these here, so let me remove these. I have a try block, and in this try block, I loop over my data list and attempt to insert each data dictionary that I have. So in this case, I set up my command. One important note here is that I'm using this formatting option, the %s. And the reason I'm using this is because this will allow me to have SQL properly use the proper quotations for these values. Again, you can run into issues if you try to quote it yourself in case the data has quotations within the string values that you're trying to assign here. So again, this will let me specify values and quote them properly so that my SQL query is proper. All right, down below, I have a method that I'm calling called Sanitize Data. The goal of this function is to take in the input data from the CSV file that we got and then clean it and adapt it so that we have the correct values for our database insert. So we go to that function above. As you can see, for the most part, we're just simply taking the data from our input dictionary and assigning it to our sanitized dictionary. But there are a few exceptions where we want to modify the data. One is for the name. In our CSV file, the name is one string with the last name coming first, then a comma, and then the first name. We, however, want to separate the first name and last name for our database records. So to do that, I use a regular expression module. I have my regex, which basically will identify the last name, which comes before the comma, and anything after, which will be the first name. I'll use those matches, which is group 2 for the first name and group 1 for the last name, and assign that to my sanitized dictionary. Finally, another modification we make is for annual salary. Our database only is going to be storing annual salaries. Therefore, if an employee is an hourly worker, we have to use a formula as specified in our requirements, where we take the number of hours that they work on average, multiply by their hourly rate, and multiply that by 50 to give us approximate annual salary. All right, so once we compute that value, we assign that to our sanitized dictionary as well. Note again that I'm using the field class, which is my convenience class, just to specify the field name so that, again, I don't make an error typing in the field name manually. And also I'm using the CSV header convenience class to, again, do the same thing, to extract the values correctly without having to manually type in the field names each time, because that's more susceptible to errors. All right, so my sanitized data just returns the proper data that I want to insert into my database, which is returned here. And then I create a tuple for my command values. Again, this will be used in conjunction with the formatting option that I have here. And then finally, I will execute my command and then pass in that tuple, which execute will take that tuple and fill in those values properly into my query. All right, so I'll do this for each data row in my data list. And then finally, on success, I'll print out a successful message and return true, indicating that this method or this function call was successful. Likewise, if there's an error, I print the error and return false. All right, so let's get to my main execution point, and we can kind of see these functions at play. So the first thing I do is call connect to database. Again, remember that's Psycopg creating a database connection, and it returns a connection object on success. So I definitely want to check that connection object to make sure it's not none. Or if it's none, I'm going to abort the application. All right, then finally I have another try block, and this is where I actually do all the work I need to. I extract the cursor object. Again, this is what I was doing incorrect earlier in the lecture. If you guys were following along, I was not calling cursor method. I was actually assigning the cursor this way, which is not actually the cursor object. So I'm calling a function on the connection object, which is called cursor, which returns a cursor object to me, and that's the cursor I actually want to use. All right, so after obtaining the cursor object, I create my table. So I specify my table name as employees, pass that table name and cursor into my create table method, which should execute a SQL query to create that table and will return true on success. If my success value is true, I proceed to read my CSV file and then proceed to insert that data that I obtained from my CSV file into the table that I just created. All right, so finally, I commit my queries and I close my connection and cursor, print out the success message, and that is my program. So again, I'm taking a CSV file, reading it in, modifying the data to make it, to format it correctly for our database insert, and then inserting the data into the database table that I created. All right, so hopefully you're able to follow along. Again, apologies for the errors earlier that I was encountering. Couldn't debug on the spot. But yeah, this is my solution for Chicago salaries. All right, thanks guys.